For each system of linear inequalities, explain what the graph of the solution would be. So on each one of these, I'm going to go ahead and explain what the graph looks like and what the solution of the system is. But how am I going to graph these, and what is the solution of a system of linear inequalities? My teaching assistant Chloe is here with her latest cheat sheet notes. First up, she wants you to know that when you are graphing inequalities, go ahead and graph all the inequalities and shade them on the same coordinate plane. Where all the shading overlaps, that is the solution. If you have any solid lines, those are included in the solution. If you have dashed lines, those are not included in the solution. Now that we have Chloe's cheat sheet notes, we can go ahead and start to look at what these graphs are. So we have y greater than 2x plus 1. Well, when I graph that one, I have my y-intercept here of 1. Slope is 2, so I went up 2 to the right 1. It is a greater than symbol, so that is a dashed line. And since y is greater than that, we are going to shade above that line or going up the y-axis. Now let's look at 3y greater than 6x plus 3. Now that is not in our y equals or our slope-intercept form, so I want to go ahead and get it in that form to help me graph this inequality. So I take the 3y greater than 6x plus 3, and we will go ahead and divide by 3 on each side to get y by itself. The 3's will end up canceling out on the left-hand side, and we will have y greater than 2x plus 1. Now notice that's exactly the same line. Both of those in that system of inequalities is exactly the same inequality. So on that one, when I graph it, it will also look exactly the same. I'll have a y-intercept of 1 and a slope of 2, meaning I go up 2 to the right 1. Now what happens when you graph these on the same line? The red and blue graphed on the same will look like this purple color. Notice that they have the dashed line at 2x plus 1 because they were both greater than that. So they were both shaded above or going up the y-axis. Now, notice that in Chloe's cheat sheet notes, where the shading overlaps is the solution. So the solution to this system of linear inequalities would be everything that is above this line. Now, how do we write that out? We just go ahead and write there the same inequality. The solution of the system would be the half plane. You have split this coordinate plane into two. This half over here where there are no solutions, and this half over here where there are solutions. Now let's go ahead and look at the second one. We have y greater than 2x plus 1, so let's look at that. So 2x plus 1, we have our y-intercept of 1, slope of 2, so we go up 2 to the right 1. It was a greater than symbol, so it is a dashed line, and since y is greater than that, we do shade above it or going up the y-axis. Now we have the other one here that says y less than 2x plus 1. So what does that look like? Well, same thing here. We have our y-intercept of 1 and slope of 2, so we went up 2 to the right 1. This one is a less than symbol, so that is why the line is dashed. And y is less than that, so when y is less, we go down or we go below the line. So when we go ahead and put that purple and black together, on the same graph, they look like this. Purple was on the top, black over here was shaded on the bottom, and they both had a dashed line at this part where they shared in common. And remember, dashed lines are not included in the solution. So because the purple one, the top one was dashed, and the bottom one, the black one was dashed, there is no solution. There's no overlap here. So on this problem here, there is no solution. There are no common ordered pairs. Now let's look at our last one here. Y greater than or equal to 2x plus 1 and y less than or equal to 2x plus 1. So on that first one, y greater than or equal to 2x plus 1, we have our y-intercept of 1, slope of 2. It is a greater than or equal to, that is why it is a solid line. Since y is greater than or equal to it, we shade above it or going up the y-axis. Now let's look at this one here, 2x plus 1. Again, we would graph that 1 as our y-intercept up to right 1 for our slope. Y is less than or equal to it. That is why it is a solid line and shading below or going down the y-axis. What happens when we graph both of these on the same graph? It ends up looking like this. And your solutions are where they overlap. So we know that y was greater on the blue, y was less than or equal to on the green, but both of them had that solid line right here. So the equation, the solution to this would be the boundary line, y equals 2x plus 1. None of the shading overlapped, but remember, solid lines are included in the solution.